Hello, grade 12, Mrs. Tole here. So today we're going to look into exponential function. Okay, I just want to do a recap with you guys here, just so that you remember. Let's say you're having f of x is equal to a to the power of x. Now, what you just need to remember here, if your a is let's say a whole number, it's not a fraction. Okay, yes, it's greater than 0, a is greater than 0, but also it's a whole number. So it means that what we are going to do here is that what you're going to see, let's have two things here. Let's say f of x is equal to 3 to the power of x. Then also maybe g of x is equals to 1 over 3 to the power of x. Okay, so for these two graphs here, what you need to remember there is that you're going to have something like this, okay, where you're having the 3 to the power of x. This is its shape. They are both passing through 1. Okay, they are both passing through 1, and the other graph here of a fraction will be a reflection along the y-axis. So here they both pass at 1, but because whatever any value to the power of 0, we get 1. That's why it has to pass at 1 there, because once x is equal to 0 there, whatever that number that we have here, whatever value that we have here, it always gives us 1. That's why it has to pass at 1 there. Okay, so that's a reflection along the y-axis, and what brings that is a fraction. So whenever you're dealing with a fraction here, you must know that the shape of the graph here is actually starting here from down here, from the top there going down the other way, and the other side also the same thing. What about if we are now having negative there? So let's say now we're having maybe h of x is equals to, let me use another thing here, maybe let's say okay, let me just put again g of x there. Let's say now it's negative a to the power of x. Now in that case, now what we are now having now is that we are now having a negative, and this negative here will tell us about the reflection, that it shows us that the graph has been reflected along the x-axis. Okay, so the graph has been reflected along the x-axis. So when you get 0, when you put 0 there, you're going to get 1, and that negative is going to give us -1 there. Okay, so that's the thing that I just wanted to show you guys about your exponential function, and also if the shift up and down, which will be brought here, if we are to say plus q, then this one, you know, that is an up and down shift. Now let's actually attend the question that we have here at hand. Given h of x is equal to a to the power of x, a is greater than 0, and a cannot be equal to 1. Now b, which is -1.5, is a point that lies on h, the graph of h of x. Determine the value of a. Now for you to get the value of a here, it means you are given a coordinate, and the coordinate consists of the y. So let me just reduce my pen there. Okay, it consists of your x and y. Okay, so in this case here, what we have here, this is our x, this is our x there, and this is our y. Okay, so now what we're going to do, we're going to substitute the value that we have here. 1 over 2 is equal to -1, not -1, sorry, there. It's going to be a to the power -1. Okay, so here, if we are to have something like that, we can just change it here. It's going to be 2 to the power -1 is equals to a to the power -1. Okay, so if we have got the same exponent, we can equate the base. The base therefore is equal to 2. Okay, so here our answer there will be equal to 2. Then write down the equation of h inverse of h in the form of y is equal to. Now, what do we know about inverse? So here it's 5.2. What we know about inverse is that we're going to interchange. So here, if we have got y is equal to 2 to the power of x, once we interchange there, we interchange x is equal to 2 to the power of y. And in this case, now we are making y subject to the formula. So make y subject. That's how we get the inverse. Here, first thing here, you interchange. Okay, interchange x and y, then after that make y subject to the formula. Now, what we also need to remember is that when we are dealing with the relationship between logarithms and your exponent, if we have got a to the power b equal to c, this is the same as b is equal to log base, same base, which is a c. Okay, so that's what we need to bring in here. So if we are to bring that, we are going to have something like y is equals to a log. What is the base? Base is 2, then x. So this is the equation that is needed. Okay, so this is the equation that is needed. Now, sketch the graph of h and h are the inverse on the same set of axes. Clearly show all intercept with axis. Now, what you need to remember here is that you need to indicate the x where the graph touches the x and y are what you call axis. So here is our y. Don't forget to label. So first, these are the things that you do first. You draw your lines, you label the x, you label the y-axis, you also put the origin. Then from there, what we know is that it's gonna pass at 1 here. Okay, it's gonna pass at 1, and the one for log is also passing at 1. Okay, so it's also passing at 1. But what we understand on these two is that they on these two is that they have got asymptotes. Okay, so they have got asymptotes. So this is the asymptote of y equal to, let's not put y, let's put h of x. So h of x. So here is our h of x. Then the other one here will be the one for the inverse, which will actually pass like that. And remember, what about this graph? Remember something about this graph is that this one here, the asymptote is the y-axis, so it doesn't touch the y-axis, and for this one here, the x-axis is the asymptote. Okay, so there we're gonna put our 1 there, so it's passing at 1, it's also passing at 1. Okay, then we can see that here, this is the line that line of symmetry here. Okay, this is y equal to x. Okay, now, so we have got h negative 1 there. Okay, that's the two graphs that we have there. So once you draw this, you get all your marks. Now, write down the domain of inverse of h. So now domain is x values. So domain here is x values. Okay, so we are worried about the x values here. So x values approached by the inverse is from 0 up until infinity. So here the answer there should be equal to x greater than 0. We can't say or equal to here because x cannot be equal to 0 since this is an asymptote y-axis. So in the y-axis, you must know that this is what you call x equal to 0. Okay, so this is x equal to 0, the y-axis, and the x-axis, it's y equal to 0. That's something that for you to remember. Now, determine the values of h. Let's go to the next slide. Okay, determine. So we're here. Determine the values of x for which h of x is greater than 1. Now, h of x is h of x. So h of x is equal to 2 to the power of, the inverse. The inverse there is equal to log base 2x. Okay, so we asked that values of x for which this log 2x is greater than 1. So we're gonna just write log base 2x is greater than 1. And remember, when you're dealing with something like this, you actually take the 2 there. X is greater than what we call 2 to the power of 1. Okay, now this is our answer there. We don't need to worry about anything. Remember, you're just solving now. You are removing, you're going back. Remember, you're coming back from log. Remember the relation that I told you about. If we have got, we had 2 to the power of x equals to y. okay? And we say the inverse there, the inverse is log 2 base x, okay? Log 2, what you call x. So there, you must remember that. Now let's move on to the next question here, 5.6. If it is given that tx is equal to 1 over 2, the power of x minus 1, describe the transformation of h to t. Now, our h there is equal to 2 to the power of x. That's what we know. Then now we have a fraction now. So what we have seen there, we have seen the fraction that is added there. So what does the fraction mean? It means that reflection along the y-axis. So the first transformation here, okay, is reflection along y-axis, okay? Then the second thing is we see the shift. This is the vertical shift. This is the vertical shift up and what called down. So here the vertical shift here, because of the negative, is 2 units, 1 unit down, okay? So it's shift 1, shift 1, okay, so that's what we have seen there. So that's what it means. So it means that this graph here is gonna it's going to be in this form here. It's gonna be in this form here. It's gonna be in this shape. So in this case here, it's gonna be in this shape here. Okay, so I'm not going to put the coordinate there because we are not answering that, but this is going to be the shape of the fraction, okay? Then it also going to be shifted downwards, but we're not asked to draw it, so there's no need for us to worry about that. Determine the equation of the asymptote of t. Asymptote of t is going to be, so remember, whatever value that you have here, that's our asymptote, okay? That's the asymptote. So here, y is going to be equals to -1, okay? So that's the asymptote. Whatever value that you have, whether it's positive, whether it's negative, you just take it as it is. That's your your asymptote, okay? So guys, all the best in your exams. Thank you so much. Bye-bye.